Good morning. How many of you are using AI? Show of hands. OK. Small number. Great. Let me tell you why AI is exciting in just 2 words. It is artificial intelligence is the opposite of natural stupidity. That's all you have to remember. That's the definition of AI. Well, I want to start explaining the power of AI using a story. Behind me here is a timeline of the Earth. It's 4.6 billion years long, right from the Big Bang. And as you follow that timeline, I want to call attention to Earth's 4 billionth birthday. That is the start of the Cambrian acceleration. You know, before the birthday, at 4 billion years, all life on the planet was single-celled, maybe a small number of aggregations of cells. And then in a very short time period of 80 million years, called the Cambrian period, all sophisticated life on the planet, including nervous systems, emerged. A large number of you know about this story. People have been wondering why. One of the most interesting theories proposed so far is the emergence of sight, the ability to see at a distance. So you might ask the question, why should the ability to see at a distance drive an incredible explosion in nervous systems and body complexity and diversity of life? Well, here's an answer. Let me take a simple predator-prey scenario. When a prey develops the ability to see at a distance, it becomes very effective at avoiding predators. Well, then the predator has to, in turn, evolve incredible senses to go catch the prey so it can survive. And now the prey then, in turn, becomes smarter. There is an incredible acceleration in evolution driven by this ability to compete and the predator-prey cycle. That's just one of several examples. Then the creatures on a planet start evolving reasoning systems, nervous systems, limbs to avoid, ways to locomote faster, and so on until a new equilibrium is reached and a very sophisticated ecosystem forms. That's what the ability to see can drive. To see, remember, is not just to register pixels on a retina, but to understand what they mean and to be able to act predictively with it. We are at a very similar threshold now in the world of software. Until now, software was really about collecting data, recording them, and writing programs against them. In the future, with AI, software becomes sentient, and it develops the ability to understand what the data means. It allows us to build models that predict things and allow us to act without being programmed. And that drives an incredible explosion in sophistication of software, makes software sentient, and it, in turn, will drive a fundamental change in the economy. So if you think about how that revolution is coming together today, the cloud, with its unlimited computing power and the ability to integrate vast amounts of data across applications, that is the ocean in which AI is being born. Data from all over, not just from regular applications, but sensors of all new types being invented, and data about all interactions and communications. All of that data is the oxygen that feeds AI. And algorithms, the advances, incredible advances in AI, such as deep learning and others, that gives us sight, the ability to see into the data and act predictively with it. All software of the future is really going to be integrating these 3 things: cloud, data, and intelligence. And they will live in that cube that integrates all of these 3 innovations in massive ways. Very powerful. And so how's Microsoft then playing in this technology revolution? We have 3 major directions. We build an AI platform for developers like you to build amazing applications on top of it. That platform is what Microsoft has been always about. It is about empowering developers to build amazing applications infused with new technologies. The second thing is about us infusing AI into every product, whether it be a Microsoft Office or Excel or Exchange or Outlook. All of these products, or even Xbox, all of these products get incredible innovation from AI. And then finally, in specific areas where there is a big opportunity to help our customers, such as customer care, where there's tremendous amount of conversational data available already, we can then apply AI to improve those customer experiences and create incredible efficiencies. So now let me tell you about the platform. So the Microsoft AI platform, it's really a first-class platform built in the cloud. It brings the best of AI to the cloud and the best of the cloud to AI. And that marriage is really important for developers looking to build complete applications, end-to-end systems of intelligence that then operate day in and day out in a 24/7 way in some workflow. So we have three major buckets or components there: AI services, the infrastructure on top of which all of these services reside, and the tooling to build applications. Let me tell you a little bit about them. So in services, we have, again, three groups. Custom AI, this is about developers bringing their own data, building machine learning models and AI models and statistical models, and then deploying them in the cloud as web services and creating hosted applications on the cloud that are reliable, monitored, and managed. The second bucket is pre-built AI, cognitive services, for example. Now I should tell you about this a little bit. Let me make an analogy. For example, these days, we rarely build buildings from brick and mortar all the way up. We assemble buildings with prefabricated parts. That's why, for example, a few years ago in China, they were able to build a hotel in 6 days and then rest on the 7th day, because it is assembled from prefabricated parts. There'll be, in the cloud, in the not-too-distant future, 1 million prefabricated AI APIs in the cloud that developers such as yourself will be able to compose into very powerful applications. What are examples of these APIs? Speech recognition, video understanding, image captioning, very powerful search, natural language understanding, sentiment analysis, so on and so forth. There's anything that you can imagine is a nice component. Think of these like almost like integrated circuits on a circuit board, right? There is, in the semiconductor industry, a vast number of integrated circuits created by manufacturers all over the world, and then you assemble them into actual products. It'll be similar with AI. And then the third bucket, conversational AI. Conversational AI is about creating chatbots and intelligent bots that can interact with you in natural ways and get tasks done for you. It's not just about a conversation. It's about task completion. It is about engaging you in interesting ways and helping you discover more. And that's a very powerful direction as well. And all of this magic then rides on top of the infrastructure of Azure. So the data infrastructure, such as data lakes, NoSQL databases, graph databases, Spark, data lakes, all of these that allow you to bring in vast amounts of data and do distributed computing and querying and processing on top of it. It also uses compute surfaces available on the cloud, such as Spark, such as data science virtual machines, such as batch AI. Batch AI is a really interesting kind of concept that is available only in the cloud. This is the ability to fire up thousands of virtual machines and schedule a job on them, and when the job's done, then you automatically shut down. It's completely elastic, and you pay only when you use the VMs for the computation. And in fact, on the cloud, if you choose to use preemptible VMs that can be taken away from you, well, then you get about 1/5 of the price of a regular VM. And that means when you're doing a machine learning training job or an AI processing job at scale with large amount of data, well, you have at least 4 tries before you actually end up paying as much as holding all of those VMs for a whole hour or more. So it's very efficient, very cheap. And then you have capabilities like Kubernetes clusters, and then things like IoT Edge. IoT Edge is an innovation that allows you to manage a very large number of IoT devices, Internet of Things devices, and put AI on them and manage the AI, manage the software on those devices from the cloud. So it's a managed collection of IoT devices. All of these are innovations really in the cloud that allow you to build amazing systems of intelligence in a variety of ways. And then there is tooling. We have great tooling, and Microsoft has typically built a very strong developer platform with Visual Studio and Visual Studio Code, which is cross-platform across Linux and Mac and Windows and so on. And we provide AI tooling on top of them. We also have the Azure Machine Learning Workbench, which allows you to do data transformations in very simple ways, and a number of other capabilities out there. It's a very rich collection of capabilities. And then finally, we are a very open platform. The algorithms supported there are not just Microsoft's. We support all the modern deep learning frameworks like TensorFlow and Caffe and CNTK, which comes from Microsoft, but it's in open source. And we support scikit-learn. And you can really bring your own frameworks, come to Azure, and develop models very easily, experiment with them, connect it to data, and then deploy these applications. So that's a Microsoft AI platform. It's a tremendous amount of detail that you can find on the Azure AI web pages. So now it's my pleasure, a real pleasure to announce an important component of this AI platform. This is the GeoAI Data Science VM. And it's an exciting step that I'm sure all of you will find incredible value in. It combines ArcGIS. So ArcGIS is hosted in a data science VM on Microsoft Azure. The VM comes pre-installed with all the popular deep learning toolkits, R and Python, and a number of data components for data exploration and visualization. And this VM can be stood up on any number of compute instances, from the smallest computers to the largest VM instances with incredible amounts of memory and even GPU support. You can use then capabilities like Azure Batch and build amazingly large-scale distributed machine learning jobs on geographical GIS data, right? And that's very, very powerful. And then once you build those models, you can deploy them as web service in the cloud and have a complete application. So very exciting. So now I want to talk a little bit about applying AI for improving the world around us. Really, if you think about it, AI is at its core about empowering people and organizations to reason and interact with this increasingly sophisticated world all around us. And at Microsoft, we believe we can help transform why we as a society can work to solve some of our greatest challenges. And I'm pleased to tell you more about this. I'm pleased to welcome Lucas Joppa, who is the Chief Environmental Scientist and founder of AI for Earth. Lucas?
Thank you, Joseph. Thank you very much. Thanks. So, thank you. So, I just wanted to start by saying how incredible it is to actually be here. The Esri Developer Summit is something that I look forward to every year, because it's really the one-stop shop to be able to come and see the incredible number and diversity of applications that all of you actually can build on Esri's GIS stack. And so I always find it hugely motivational. I've been particularly looking forward to this year's event because I've been really excited to finally be able to tell people about the GOI Virtual Machine that Joseph just described. And the GOI Virtual Machine was really intended to empower data scientists and developers to be able to build applications that classify, observe, and make predictions from and optimize over this incredibly increasing amount of geospatial data that are coming from sensing systems like GPS tracking devices, IoT deployments, and this rapidly increasing constellation of high-resolution imaging platforms like satellites and drones. And as most of you already know, I mean, over 80% of data that's already out there already has some sort of spatial component to it, and that's only going to increase. And so I spend most of my time in my job thinking about how to apply advances in artificial intelligence to spatial data in order to change the way that we as a society manage, model, and ultimately think about sustaining Earth's natural systems in a fairly different manner than we have been doing in the past. And to just kind of, I guess, explain where I'm coming from in that space, I would just tell you, I guess, a one-sided argument that I've been having most of my career with Captain Kirk from Star Trek and his description, his famous description of space as the final frontier. And that's because it's an argument, because I think that, of course, space is the final frontier. But for me, space isn't about the moon and the stars and the outer reaches of some distant galaxy. Instead, by space, I mean the space all around us, or the study of geography, or as Jack Dangerman and our friends at Esri would say, the science of where. And I say that it's unexplored, or the last frontier, because we really are, in many respects, flying blind with our understanding about the planet that we call home. I mean, I think there's a little bit of irony if you think about the fact that astronomy as a science has been fundamentally transformed by artificial intelligence already. It's machine learning algorithms that scan and sift through the incredible amounts of data being collected every day from telescopes and satellites and extract the semantic information that accelerates the work of astronomers in identifying interesting observations in distant galaxies. But here on Earth, our ability to understand what is where, how much is there, and how fast it is changing is at a much reduced capacity compared to where we are with astronomy. And so at Microsoft, we really want to help change that. As Joseph said, I have the honor of serving as Microsoft's first chief environmental scientist, and as part of that, helping the company roll out a new 5-year, $50 million commitment to a program called AI for Earth, which is a program dedicated to deploying Microsoft's deep investments in artificial intelligence to solving critical environmental challenges. And we have some big challenges, as I'm sure you are all aware, and if you pay attention to the news or read scientific journals. We find ourselves at a time where we have to somehow figure out how we're going to mitigate and adapt to changing climates, ensure resilient water supplies, sustainably feed a rapidly growing population, a human population growing to 10 billion over our lifetimes, all while stemming an ongoing and fairly catastrophic loss of biodiversity. So fail, and we're going to pay a significant price. Succeed, and we're going to have made a pretty important contribution to the human experience. But in order to succeed, I'm convinced that we're going to have to do exactly what Joseph was just explaining to all of you. We're going to have to teach computers how to see into and extract information from this incredible archive of raster and vector data that we've been collecting over the years and will only increasingly continue to collect moving forward. And that's why, from the very beginning of the AI for Earth program, we turned to Esri's geospatial toolkit to both accelerate our work and to allow us to start thinking about how we could directly integrate Microsoft's AI services, applications, and algorithms with Esri's GIS stack. And that's really where this GOI Virtual Machine came from. It's the preferred go-to platform for my development team, and it's intended to allow developers and data scientists to seamlessly work between these two seemingly, at least occasionally seemingly disparate worlds of GIS and AI. And the way that we're allowing people to move between those worlds so effortlessly is through simple, easy-to-use Python and R APIs. And what that means now is that it doesn't really matter so much from a technical perspective if you are principally a GIS developer or somebody who spends most of your time thinking about how to build AI-first applications. Now you have all of those tools available together on a single scalable machine backed by the incredible elasticity of the Microsoft Cloud. And so one of the first projects that my team and I took on, and what's turned out to be one of our more interesting and difficult projects with the GOI Virtual Machine, was a partnership between Microsoft, Esri, and a small nonprofit on the East Coast called the Chesapeake Conservancy. And what that partnership was trying to do, and still is trying to do, is to empower more people in more places to sustainably manage their lands. We want to do that by providing information about land cover at a national scale, at 1 meter resolution, which would be the first map of its kind here in the United States. And the way that we're working by taking advances in an area of artificial intelligence called deep learning, and a specific class of algorithms called convolutional deep neural networks, in order to classify freely available high-resolution imagery, like you see in one of these hexagons here, into labeled, classified land cover data on categories like forests and fields, water, and impervious surfaces like roads and houses. And so this project, one of the things that really motivates me about this project is, of course, the conservation aspects, but also the fact that it's a fairly canonical example of requirements across some of the world's biggest industries, whether that's retail or defense, municipal planning, or natural resource management in areas like agriculture or forestry. And the thing that we found so empowering about having Esri's GIS stack embedded in our AI development environment is because, of course, now we have instantaneous access to Esri's solutions for all of our traditional GIS workflows, things like data visualization, rationalizing these kind of the incredible diversity of geographic coordinate systems and projections all together across many different data sets. But we can also use ArcGIS Pro in this instance to operationalize our model. And so that's what I'm showing here, actually using ArcGIS Pro's raster functions, where in the upper corner, you can see that we're showing 1 meter resolution imagery from a location on the east coast of the United States. In the pane next to it, we're showing the data that our model was originally trained on. And then in the bottom two panes, I'm showing the output of our model, which we're able to create instantaneously by using raster functions, passing that image to our deep learning model using Microsoft's Cognitive Services AI libraries, and then immediately visualize the output of that model and allow anybody using the application to pan around the United States, and ultimately giving people the capacity to calculate land cover statistics over the almost 10 trillion pixels at 1 meter resolution that make up the United States. And I didn't talk about how we actually did that. And I know this is a developer conference. And so the reason that I didn't talk about that is because my colleague, Mary Wall, is actually going to be going very in-depth in a technical tutorial on this project at 2:30 in the Scalable GeoAI in the Cloud session. And I would highly encourage anybody who's interested in how you might be able to work on the GeoAI VM to spin up a GPU-backed deep neural network and ultimately, after training it, embed it and operationalize it inside ArcGIS Pro. Please go see Mary's session at 2:30. But between now and then, I would just leave you with this, which is that at Microsoft, we're investing in AI for Earth because we fundamentally believe in the power of artificial intelligence to change the way that humans and computers can work together to solve some of our most pressing environmental challenges. And so if any of you or your organizations are working in the 4 areas of climate, agriculture, water, or biodiversity, and interested in how an AI-first approach might accelerate some of your work, then I'd highly encourage you to go look up the AI for Earth program, apply for one of our small seed grants, use those Azure credits to provision one of these new GOI virtual machines, and start to experience everything that's possible when you have the full power of Esri's GIS stack and Microsoft's AI solutions all together for the first time. So thank you very much. And Joseph, we can switch back over. Thank you.
So 3 points to make. One, AI helps you understand everything. In the past, we could analyze statistically traditional data, which is structured data, numerical data, vector data. But now, the vast amount of new data that is being created is unstructured data like images, raster data, which you can now understand with AI in so many different ways. You can get deep insights into them. Then there is text data. There is data from sensors that are streaming in, time series, and so on. Vast amount of this data, if you don't apply sophisticated analytics and AI and signal processing and other concepts, really you can't use. And that's one of the areas where AI comes in a big way. Second thing is about reasoning, learning, developing models, predictive models, and forming conclusions and deploying them in production workflows. And then the third one is about interacting intelligently with people and allowing you access to very sophisticated levels of information and knowledge and integration. It's not just data. Data now being taken to a new level of knowledge and insight and then being correlated. So let me now give you examples of a number of these things and show you a few demos. So I want to tell you about some of the capabilities in the Microsoft Cloud that allow you to get this kind of deep understanding into unstructured data. For example, we have vision APIs. The vision APIs allow you to recognize faces. We just recently released and updated the face detection API. You can verify people. For example, Uber uses it. When a driver gets into the car, how would Uber itself know that the person who's actually driving is the person who registered the Uber account? So what they do is ask you to send a picture, take a picture, and send it, and it'll match it with the image from the driver's license. So that's one example. But you can also do identification. Now, we just launched an update where you can identify people from among 1 million faces, up to 1 million faces. So you submit a picture. It may be coming from a camera. You can, with reasonably high confidence, pick the right person and identify them. This is one example of several things. It would be very useful for security, for example. But then there's a lot more to vision. We have a great optical character recognition system. It recognizes natural handwriting very well. You can take an image and get a caption out of it. It gives a textual caption for an image. It understands what's in the image. Very powerful. Then speech. This is an area where Microsoft has incredible years of experience building world-class speech recognition systems. And not only can you really recognize speech in many languages, but you can actually customize the speech to your language, to your vocabulary, and to the domain using custom speech. That's very important. Then there's language translation. In fact, Microsoft's language translation is used by even one of the largest Chinese companies to communicate with its multinational employees. And it's a simple API on the cloud. Then there is knowledge. And then there is capabilities like search. Microsoft's Bing search engine is one of the widely used ones now with about 20% market share. That comes as an API. And that API itself is very useful to integrate into a developer's application. Now, these are just a start of a very large number of pre-built components that you will see on the Microsoft Cloud. And it can be applied to any type of data. So here's an example. This is actually an image from one of our customers. They wanted to organize and understand all of that information in the cloud. It happens to be the Nigerian Ministry of Justice. Now, their challenge is to scan all of that information, organize it, and understand it. How do you make that possible? Well, by applying a lot of the capabilities that I just mentioned, we can make headway into these. The best way for me to show you this is with a demo. So let's step back. On November 22nd, 1963, in the streets of Dallas, a lone gunman assassinated President John F. Kennedy. Or so they say, right? There's so much controversy around this that 25 years ago, more than 25 years ago, Congress mandated that all documents assassinated with the JFK assassination be released in 2017. And so how much data is that? The first tranche itself was about 34,000 documents, and it was a stack 17 feet high, and then they kept releasing vast amounts of these scanned documents. Now, wouldn't you want to understand what's in all of that? But I could spend a lot of time trying to read and parse and make connections among them, but now we have AI to help. And how do we do that? You know, one developer in my team just scanned in all of these, just took all these scanned images, uploaded it to the cloud, applied AI to it, and here's what he did. He just, he read it, enriched it with all of these cognitive services that we have, and then put Azure Search on top of it and created a simple exploration interface. All of this in about a couple of weeks, one smart developer doing it. And by the way, this agility is the power that the cloud and AI capabilities in Microsoft's AI platform give you, right? So here is an architecture. We had the data being brought into Azure storage. Then we apply enrichments, optical character recognition, captioning of vision, natural language, and so on. We create those annotations. We store it in a graph database, something called Cosmos DB. And then, as a first approach, we put search on top of it. So now let me show you the kind of insights we were able to find. I mean, really, there's lots of amazing things in there. So I bring you JFK Files. So I'm just going to bring up Safari. There is an application that we built using that architecture that you saw. This is the JFK Files. And in fact, everyone can go to jfkfiles.2.azurewebsites.net. Let me type a simple query here into the search. So I'm going to search for Oswald. And so look at what we found. All of that data was automatically extracted. And then after OCR, on the left, you have all the key terms. So it's a keyword extraction, key entity extraction API that has been applied to it. And just the key terms are here on the left. And I could select any of them and get a subset. But then here are all the documents, a large collection of documents that relate to Oswald or have a mention of it. Remember, these are images. Now they have been understood. And the keywords like Oswald have been highlighted. Now, the most interesting thing is, let's look at this handwriting, for example. So there are documents like this that are handwriting. And I think I have to show it. OK. So you will see Oswald has been recognized in yellow. And it's actually somewhat rather difficult to understand handwriting. But it actually shows up here on the right. And that handwriting recognition has made it possible. Then let me show you something interesting. If I click on this image, you'll see the image itself has been captioned automatically. Now, it says Lee Harvey Oswald. If you look at on the right, it says Lee Harvey Oswald posing for the camera, right here, New Orleans, LA 112723. And that's actually from the image itself. It recognized from the image New Orleans, LA 112723. And so it did some great optical character recognition. And in fact, I can apply some really interesting ways to recognize. So here is a graph that was built. The graph shows all the relationships that Oswald had with other people. And here is people like Sylvia Duran. Sylvia Duran happens to be a go-between between the KGB and Oswald. And so if I search for Sylvia Duran, then there'll be a whole collection of documents that come up. So on and so forth. The key thing is now we were able to digest all of this data and understand it and make these relationships very, very visible. And so, let me show you one interesting thing. When a government releases this incredible tranche of classified documents, etc., you hope your name isn't in there, right? Well, my name isn't in there, but the name of one of our products is in the JFK files. I searched for SQL in that, and so it turns out I find a document with SQL Server in it, and this is the document from the CIA, and they even gave us a wonderful architecture here, right? So this is that architecture diagram and all of that. The thing that is really magical here is, we didn't really know anything about this. It is all extracted by OCR and cross-correlation in the data. And capabilities like this allow you to relate what we found with all of these other concepts. So that's sort of the magical ability to explore the data. And going back to Oswald, for example, so you can see all these relationships. You can click on Sylvia Duran. You find that Sylvia Duran's previous statements are there. She was a go-between. She was meeting the KGB officer in Mexico. So there is this Mexico connection, etc. So this is a Mexican. She's a Mexican citizen. Somehow that was there. And the ability to just browse through all of this and even understand very sophisticated handwriting, all of that is now possible. SQL Server was used by the CIA to develop a secure classified information facility and to store all of these documents associated with the JFK files in 1997. And what was really amazing was they had this entire architecture. Data came into blob storage. There is a serverless compute capability called Azure Functions that are in the cloud that can be used to orchestrate services in the cloud, such as optical character recognition and computer vision and entity linking. We did all of that. And then we took those annotations, put it in Cosmos DB. You had a cognitive skill set. You then put Azure Search on top of it. And we even built some custom AI for really doing topic extraction on that data so that Azure Search can now understand topics as well. So you bring all of those things together, and you have an architecture that anybody, in fact, any developer here can build. And remember, these things are very easy to build because of fully managed services in the cloud. It's assembly of prefabricated components. And capabilities like these are in incredible demand across enterprises. So for example, for analyzing legal contracts, for understanding engineering plans, for extracting form information, and so on and so forth. And any type of data, unstructured data, can now be digested and organized. So that explains how your AI is able to help you gain deep insights into vast volumes of data. So now let's talk about reasoning with such data. And one of the things you can do now when you have vast amounts of data is to predict things. For example, one of the work that we did collaboratively with Esri was to predict accident probability with Azure Machine Learning and ArcGIS. Here's how it works. You get ArcGIS maps and data. You use Azure Machine Learning to do some code-free data wrangling. Then you develop models with it, predictive models for accident probability using Jupyter notebooks. You train machine learning models there. Then you're not done there. Now, the challenge is for you to build an entire application and deploy it live, right? So it can be used in production. So what we do is then you can Dockerize the machine learning models along with the associated code and create web APIs that would stand up on a Kubernetes cluster and serve these predictions off of the cloud. So the best way for me to explain this is with a demo. To do the demo, let me invite Omar Maher, who is the AI lead at Esri. Omar?
Yep. Hey, Joseph. Thank you. OK, so we can have the slides. Hello, everyone. How is your day going? Awesome. Thank you. So this is a very unfortunate event that we see on a daily basis. It's causing 1.3 million deaths a year, 35 million injuries or disabilities. It's the 9th leading cause of death globally, and it's costing $518 billion annually to deal with road car crashes. And the question is, can we use machine learning to fight this? And the answer is yes. We're going to use ArcGIS with Azure Machine Learning to predict the probability of accidents per segment, per hour in Utah. But before jumping to machine learning, we asked ourselves, what could cause an accident in the first place? Is it weather features like temperature, rain, fog? Or time features like time of the day, rush hour, day of the week? Or spatial features like proximity to intersections, or road sinuosity, or the direction of the road, or the sun direction, or other factors? In fact, we believe we are dealing with tens of variables. And the kind of data we're analyzing to train our model is really large. We're talking about 7 years of data, 400,000 accidents, 500,000 segments. It's nearly impossible for any human being to manually analyze this and predict, right? But we think we have a shot with machine learning. So what we're really going to do is the following. We're going to develop our model using ArcGIS Pro to prepare the training data set and pass it to Azure Machine Learning Workbench to train our model. Once we have a trained model, we want to deploy this into production. So using Azure Cloud Services, we're going to deploy our model on a Kubernetes cluster. And this is a Dockerized container. And once the model is deployed in production, you can think that it will need real-time feeds to produce results and predictions, right? And hence, the need for ArcGIS Enterprise on Azure. So the model would receive different feeds, like the time and the weather feeds, produce predictions for the accidents, and send it back to ArcGIS Enterprise. Once it's available on Enterprise, it could be accessible to the whole company, right? So a single source of a system of engagement where people can develop apps, web maps, etc. We have built a geoprocessing service that acts as a web tool that would invoke the model either in hourly schedules to produce hourly information products or dynamically as needed. So as you can see, we have the data, the model, and the analysis all in one place in the cloud. So why don't we start seeing this into action? Let's have a look. So what we really started to do through the demo that you're going to see right now is we have collected all the data sources, like the accidents of the 7 years, the road network layer. We have spatially joined these, added the average daily traffic for every segment in Utah, the intersections, whether they are signalized or not, weather feeds coming from about 27 weather stations. As you can see, there are lots of accidents happening near intersections, so we thought about proximity to intersections as a feature to our model. And we extracted different spatial features as well, like the road curvature or sinuosity, the road direction, the number of lanes, the road width, etc. And we added the billboards data set to see if there is correlation between the location of billboards and accidents. Now, all of this processing could be automated using ArcPy. We have used Python through ArcPy to create our geodatabase and get our data, whether from online sources or physical sources, and did some data processing, and really, most importantly, extracted the spatial features. So the kind of features I've been talking about, which is proximity to intersections, the direction of the road curvature, and other features. And finally, we joined the weather feeds and the road collisions to road segments. And after we did so, we want to load this kind of data to the Azure environment. So the first step is using the Python API to load the data from the geodatabase to the CSVs, and then transferring those CSVs to Azure Blobs, which is an amazing data storage mechanism. Once our training data is available in Azure Blob Storage, now it's accessible through the Azure Machine Learning Workbench. So let's have a look at this. So the first thing, Azure Machine Learning Workbench provides amazing data wrangling and preparation experience. You can see that this is our training data set. So for every accident, we have different spatial, weather, and temporal features, like 40 features in total. So you can see here that we have the speed limit, the surface type, the road orientation, some weather data, etc. So we can do lots of things here, like, for example, removing columns, producing histograms, producing column statistics, you name it. So once we think our data is ready for training, we just start the training process. So basically what we're doing is we load our training data that you guys have just seen, and we start to select our model, which is gradient boosting. Gradient boosting is a very powerful machine learning technique. Not only it's good with predictions, but explaining why these predictions happen in the first place. So we are splitting our data into 90% training, 10% testing for validation. We are optimizing some parameters like the maximum depth per tree, the number of trees, and others. And we are just starting the training. One other important aspect of Azure Machine Learning is the Azure Log Service. It's a very interesting service that you can log and record the different statistics of your model that you want to visualize after that. So let's have a look at the output of the Azure Log Service. One important aspect in the data science process is that you iterate continuously. So we would want to have insights along the training process, like what's the duration of the training? What's the value of the F1 score, the precision, the recall, the accuracy, etc. Azure Machine Learning records every cycle of those training. You can click on any cycle and explore it in more detail to help see how is your training process going into action. So for that cycle, we can see all of these details, like the scores I've been talking about, and you can see the visualizations we have been capturing through the Azure Log Service. So now we think we have a trained model that is producing good results, and we want to deploy it into production to be accessible to the whole enterprise. Azure Machine Learning has a dramatically amazing experience to help you deploy your model really easily. So the score file, you're going to find it as a default file in any kind of Azure Machine Learning project. And it comes with a skeleton that helps you develop the needed functions. So for example, defining the schema for the REST API for the model, initializing your model, like passing the data and the model itself, and finally, the scoring function, which is the function that's going to take the real-time input, like the time and weather, and produce the output. And the final stage here is deploying that model to the Kubernetes cluster using the Azure Cloud Services. And what's really good about this is the scalability. So it scales dynamically based on the need, right? So as the number of users, as the number of requests grow, it scales dynamically. So let's have a look into the results of that model. So again, what we want to do is predicting the probability of risk per segment per hour. Today is December 3rd. It's a rainy and icy day, and it's 3 p.m. We are close to the rush hour. And we are seeing the Woods Cross area in the Salt Lake City. So where is our algorithm predicted the highest risks? Here we go. Red is the highest risk, orange is still high, but not as red, and green is the least, which is safe. We can see that the risk is mainly in the interstates and highways and some internal roads here. So what about seeing where the accidents did actually happen? Interesting. They are happening mostly on those segments we have predicted, not only on the highways and the major ways, but some inner roads as well, like that one here and that other one here. And you can explore the degree and the effect of road curvature on that. And here's South Salt Lake area, which is really near to the Salt Lake downtown. So our model predicts that those interstates and highways are really risky, and some internal areas here. You can see, for example, that this is more greenish, this is a more reddish and oranges area. And again, the accidents are happening on those intersections we have predicted. And we can see a pattern here that many of these accidents in the inner roads are happening on or very near to intersections. Finally, for the South Valley Regional Airport, these are the model predictions, and these are the actual accidents. Again, some internal and curvy roads besides the highways. So what we have seen today is using ArcGIS with the powerful Azure Machine Learning tools to help predict the probability of accidents per segment per hour and fight this global phenomena and save more lives. Now, this is not the only example. In fact, there are more examples that we have used the Microsoft AI services together with ArcGIS. And we're going to show this today at 2:30 p.m. at the Scalable GeoAI Experience in the Cloud session. So I'm really excited to share with you different examples today and see you all. Thank you.
Thank you, Omar.
Thank you.
Great demo.
Thanks, Joseph. Thanks.
All right. So now let me talk a little bit about interacting. Conversational apps have become the replacement of intranets of yesterday. When the internet technology came, most enterprises said, can we harness it to make our internal enterprise information visible and usable? And now people are taking one step farther and putting conversational interfaces in front of it. And why is this interesting? Now imagine, for example, the use case of one of our customers called Unilever, a very large multinational company in 130 different countries. And they had to provide HR support in all of those places. Typically, when a Unilever employee, for example, does an HR task in one of these countries, like let's say someone gets married and wants to change their last name. They go through a number of steps, and it may take up to a week to get your name changed across all of these systems. And now, after they've launched a conversational interface, an HR bot, that whole process takes 3 minutes chatting with a bot. It's so much more efficient and so much more natural. Now, let me give you one simple example of this capability in action. So we took the ArcGIS online help that's out there and asked ourselves the question, how quickly could we put a bot in front of it that allows you to answer the FAQ very, very simply? And so here's a bot. The bot's created. Now you can go to Facebook Messenger and start talking to it. So I'm going to play a quick video that actually shows how this works, right? In 35 seconds, you'll have a bot. So this is a small application we put together called Bot Maker. I gave it a couple of URLs. So now I gave the landing page content. There is the FAQ link, right? And this is all from the ArcGIS website. And this is happening in real time, by the way. And so I give it a couple of URLs, FAQ URL, and then say create. And when that's done, what's happening is behind the scenes, a whole bot is being provisioned, and a chat window comes up, and now you have a chat bot live right there, and you can ask a question. Can ArcGIS be integrated with Bing Maps? And that questioning, you can ask the question in many, many different ways, and you immediately get an answer, right? So in 30 seconds, it's possible now to stand up an intelligent chatbot. Now, it won't be perfect. It can be improved. But the thing is, when you put these conversational interfaces in front of systems, you set up now an opportunity for you to learn from interactions with people, understand what questions are not being answered, now tweak your text models to answer those questions better, and have a continuous learning loop, and the chatbot becomes better and better. For example, Progressive Insurance did this a few months ago, built a chatbot called Progressive Flow, and they sold their first auto insurance policy over a chatbot in November. Right? So every kind of this customer interaction is now going to become better and better and automated with chatbots. So now here's a brief summary of what the AI platform is capable of doing. So you can build these powerful understanding applications using cognitive services. Then you saw Omar Maher talk about building custom AI models from data using Azure ML and GIS data. And you can build conversational AI using bots, right? These are sort of the first step of infusing understanding into software. And AI now, because of all of this power available to developers, is truly becoming the new normal. You touching AI every single day on your mobile phones, every recommendation, every spam filter in your email, every fraud interaction, or rather, every fraud screening that happens in payment processors, all of these things are driven by AI. And now, capabilities like chatbots are taking it to an entirely new level as well. Now, AI can be also very empowering. And I wanted to share with you a very profound story from an ISV that built an application to help mothers communicate with autistic children. And I'm going to play a video, and then I'll explain what that application does.
Arthur, c'est un autiste sévère qui n'a pas de langage, donc qui a une compréhension assez basse des choses, assez petite, et qui a 15 ans. Il était à la crèche. À un moment donné, on a eu l'impression qu'il ne nous entendait plus et le regard était plus vide. On est allé voir une pédiatre qui nous a dit tout de suite, il est autiste. On n'y croit pas. Ce qu'on lisait, c'était pas possible. Il ferait pas partie de ce tableau. Et il a fait partie du tableau le plus sévère qui existe quand même. Aucun langage, il saute partout, il crie beaucoup. Donc voilà, c'est bien fatigant le quotidien. Quand il s'énerve, c'est quand même qu'il n'a pas compris quelque chose ou qu'il veut quelque chose. Le classeur, le PEC, c'est pas quelque chose d'évident, de facile. On n'a jamais la bonne carte elle est perdue, elle est tombée sous le fauteuil. On a quand même un peu ramé. D'où l'intérêt pour lui de communiquer avec El Picto. Je parle, je donne une information à Arthur et elle est traduite par l'application El Picto instantanément en pictogramme. Peur. Et après, d'une façon orale.
Microsoft a développé ce qu'on appelle des cognitive services, mis à disposition dans le cloud de la reconnaissance d'image, de la reconnaissance vocale et des traducteurs automatiques de langue. Et ça, c'est important parce que c'est nous donner la possibilité à nous, PME, d'accéder à ce qui se fait de mieux en matière d'intelligence artificielle.
C'est beaucoup plus ludique, plus facile, il comprend mieux. N'importe où, en forêt, on se balade et est-ce que tu veux boire? Est-ce que tu veux faire pipi? Est-ce que tu as faim? Ça paraît pas grand-chose, mais en fait c'est énorme cette différence. C'est vraiment énorme.
Plus on utilise El Picto, mieux ça fonctionne. Le modèle va continuer à apprendre au fur et à mesure pour faire en sorte de l'optimiser et de le spécialiser.
L'autre jour, j'ai appuyé sur « On va se doucher ». Il regarde la tablette et il va dans la salle de bain. Il n'y a pas eu de cris, il n'y a pas eu de larmes. Enfin, c'était waouh, c'était super, quoi. Des petites choses comme ça, c'est une grande victoire.
Amazing, isn't it? That was an enterprising developer with a powerful idea. He asked himself the question, why is it so difficult for a mother or a caregiver to communicate with an autistic child? Why should it be so difficult? Now, the way they communicate is by taking pictures from that book and assembling them to really communicate through pictures and at the same time speak. But here's what the developer did. I said, OK, instead of pictures from a comic book, equivalent of that, why couldn't the mother take pictures from the household that the child is already familiar with? Images of cups and butter and other things. Can't I use that to communicate? Now, couldn't the mother just speak? Couldn't speech recognition understand what she's saying? And then recognize the entities in it, match it to the cup and butter and things like that, and compose a conversation. And then couldn't I show this all on a mobile device so that on an iPad, I could actually hold it and share that and show it to the child and speak at the same time? That's what he did. He used Xamarin, which is a cross-platform mobile development platform from Microsoft, Visual Studio for mobile, to build a cross-platform app. He took images. He made it very simple for the mother to go around the house, take images, put that in. The Vision API understands what those pictures are, so it labels it with the right name. So a cup is recognized as a cup, and a text is in there. Then he used the speech recognition. So when the mother speaks, the speech recognition is automatically done. Then the key terms are extracted, and those are matched to the labels or the images that are there. And then that conversation is composed on an iPad, and that allows the mother to communicate. This is a new way of interacting that he created. And how many of you, well, if you have an Android or iOS, you can also see other applications like this. There is an application, a very powerful application called Seeing AI that was developed by some Microsoft researchers, which allow the blind now to see the world. They can point their camera at an object, it recognizes the object. You can show it at a room. If I show it here in the room, it'll say a crowd of people. In a smaller room, it'll count the number of people. You can even show it currency, and it'll recognize how the currency and the dollar value of it, and so on and so forth. And it's so good, now there are even people taking the Seeing AI app, putting it in front of a TV and watching TV with it. So all of these capabilities are now coming to light. See, AI has the power to empower us all. It's actually really amazing, the capabilities that developers such as yourself, when you combine the power of AI with the data, can potentially build. And finally, then I wanted to show one more thing here, where you can get a lot of resources. If you go to Azure AI Gallery, there are a very large number of examples of these kinds of capabilities that can be realized. And you will see industry, solutions, experiments, machine learning APIs, custom modules, and so on. And so if you click on, say, aerial image classification, you see a whole lot of documentation here. Describes what to do. You click on View Project, and you will see a GitHub page with aerial image classification. Lots of details about it. If you go back here, there is just a very rich collection of things. So if I go to solutions, in this page, you will see solutions for the edge, carbon emissions data platform, for example. If I click on this, you'll see how to build a model for, in this case, real-time carbon emissions and global weather data. You can click Try It Now. There is a Power BI dashboard that will be available soon for that one. And if you click Deploy, it walks you through a whole process for deploying it. You have to sign in. But it's a very, very rich collection of examples. I can even find, you can pick many, many topics, and you'll find it. Like in this case, I just type heart, and you'll see heart disease prediction, machine learning models for that. There are, I say predictive maintenance, and then you'll see a solution for predictive maintenance of aircraft. This is identifying components, identifying component failure. There's a whole architecture, and so on. So I invite you to go to Azure AI Gallery, look at all the resources that may be available. Many of them are instantly available for you to try and develop with. There is code, there is machine learning experiments. There's a vast collection of these capabilities. So now let's switch back to the PowerPoint. And I'll point you to some of the resources here. Azure.com/AI is a place to start. AIschool.microsoft.com has a tremendous amount of training material. Azure AI Gallery has a large number of examples. So it's a wonderful place to start. And I invite all of you to get on this journey of applying AI to geospatial data and all types of data to create magical software of the future. Thank you.